Bye. Have a good one.
Have a good day.
Bye-bye. All right, good. Moving on, perfectly on time. Our next speaker is no stranger to our community. Rick Vasquez is the man. He is Rick Vasquez II. He has a wonderful T-shirt on, and he's in Texas. Good morning, Rick.
Here we go. Look, we're matching today, aren't we?
Yes. All right, Rick.
It's all a series of matching.
It's all you.
Okay, thank you. Can everybody see my screen? Okay.
Yep. Yeah, I can see your screen. Yep.
Perfect.
Maybe I can't see you very well though. Have you got any extra light you can put on?
It's like I'm in the witness protection. Is the joke that I always tell people. I'll get closer to the webcam so it'll focus.
Okay. You're cool.
There we go.
Yeah.
So what are we going to talk about today? We're going to talk about me specifically making a call to database management systems, anybody who writes them, to modernize them for Kubernetes. Right now, we're living in 2021. Kubernetes is on time releasing all the time, and yet what we're seeing from any databases that are out there, not just RDBMS or from the highly relational, even the NoSQL stuff, we're starting to see left in the dust from Kubernetes, where they're not leveraging the full capacity or the full feature set that the databases of today can really shine if they used everything that there was to offer in Kubernetes. So who am I? I got my start with Kubernetes actually a little late to the game while I was at Percona. I've been at Percona, I recently left, since 2016. And so through that, I lived through the evolution of, all pure stateless to stateful sets. And, I'm a convert from you should never run a database in a container, let alone in Kubernetes, all the way to what I'm talking about today is we really need a push for everybody to have their main deployment style be in Kubernetes. The real benefit from working at Percona for so long is everything that I've been focused on for as long as I've known about Kubernetes has been at scale enterprise grade use cases. So instead of worrying about what dev environments are, what cool things can we do as proof of concepts, I'm trying to look at the world in a way that this is applicable at a global scale for some of the largest companies in the world. So one of the things that I've run into quite a bit whenever I talk to engineering teams from the various different companies that are either the corporate sponsors or the people making main contributions to some of the databases that are out there, is they treat Kubernetes like an operating system. Does it run there? If it does, right, then it's not my problem. It's somebody else's problem to actually make it do cool things in Kubernetes. So these are some of the things that I've heard over the last 3 or so years about Kubernetes. So why is Kubernetes treated like one, right? So everybody, the first thing is, does it run in Kubernetes? Well, yeah, I mean, if it runs in containers, it'll probably run in Kubernetes. But that's really the wrong way to look at what a database workload is supposed to be doing in Kubernetes. Well, the answer to that is just let Kubernetes handle it the way that it wants to. Because Kubernetes has its own paradigm and it has the way that it interacts and sees the world. So just let it do things to our application in Kubernetes. And while that's getting warmer, why can't the database actually communicate with Kubernetes and have Kubernetes do things for it? Which is really kind of the next evolution and what would make something really powerful. I've heard a lot of that's out of scope. All we need to do is make sure that the database, the storage engine, it interacts correctly. It can do all the things it needs to do. Everything else, that's all fancy, automated failovers and good upgrades and all that. That's not in scope for a main database. And my answer to that is like, what is this, like 2016? We're 5 years since that has that ship has sailed quite a long time ago. Right now, what's really important to a lot of people are exactly those things, and that's why Kubernetes is the bigger and bigger answer as we move forward through time. And then the one that I like, and this is the kind of the latest answer, and a lot of companies that I've worked with really closely are really guilty of this. We have an operator for that. So instead of building it into the actual database itself, they say, oh, we have this separate team, and then they do Kubernetes things, and it makes our product work really good in Kubernetes. And I think that's a really good step forward in the right direction, but I don't think that operators are actually the answer to making the deployment style in Kubernetes for any database ubiquitous. I think really what you have to do is bake it in like it's built for Kubernetes. Um, so what is Kubernetes? And this is going to be really refresher for this audience, but the main things, and this is from their documentation: service discovery, load balancing, storage orchestration, automated rollouts and rollbacks, automated bin packing, self-healing, secret and config management. Um, all really, really powerful things that allow for you to have a really consistent developer experience, SRE experience. The name of the game with Kubernetes is driving consistency. And so you can use Kubernetes to become globally consistent across your deployments and do them in the same way over and over. But why hasn't that bled through into databases? And really, the operator framework is a way to say, hey, you can get all of these 6 great things from Kubernetes, and do it the way that your database thinks that it should be implemented. And really, the question that I always ask myself is, wouldn't it just be great if your database did that? All of the 6 things that we just talked about, why doesn't the database just do that from native? That seems like something that these companies would really want their databases to do. So imagine if you have Postgres, Mongo, MySQL, Cassandra, and any database that's really popular out there right now, and it was built natively, right, starting from today on Kubernetes. And so what would you do? Well, you would say, well, hey, I have access to be able to use different storage tiers. I can use local disk, I can use remote disk, I can use different tiers of both of those. And all of that is declarative in some configuration objects. So why can't I just configure that in a database where I say, hey, I want my MySQL thing, I want logs to be on local disk because I don't want any bottlenecks. I want these tables or whatever to be on some slower disk that may be over the network. And then I want this disk, I want the last 7 days to be in hot local NVMe. And then I want the rest to be off in some. Those things really start to be possible whenever you start building with these paradigms native internal to the database. And then you're leveraging Kubernetes as the platform. So allowing physical migrations from the database viewpoint, not the application viewpoint, instead of having to worry about failover from the application because you're going to move from one rack to the other and you have to change host names or you have to worry about DNS or anything like that. What if it just worked? What if it was just going to accept writes maybe in both places for a while and it was completely transparent to the application? Those things are possible in Kubernetes, especially with the load balancing and configuration that's available through Kubernetes. Having databases that recover quickly and leverage all of the hardware that's available. I mean, this sounds like a dream come true. Who doesn't want a database that is survivable? And Cockroach is doing a really good job at hitting on really this aspect of their Kubernetes based deployments, is having something that is fault tolerant, can survive, can come back, is really cool. And it's something that is a lot easier in Kubernetes due to the automation than it is anywhere else. So having databases that scale up, down, out, back. The problem right now that everybody faces is, oh, okay, yeah, so you've got something that can be deployed in Kubernetes. But the database itself doesn't think about or doesn't have an opinion about how big it is. If you make it bigger, that's great. It just needs more resources. So you can set auto scaling to get you bigger, or horizontal scaling from a sharding perspective. You can have some mechanism that says, okay, I'm going to split a shard. And then once you do that, but what happens whenever you want to use the true elasticity that's given to you by Kubernetes? It's not just the scale up and out, it's the scale back and down. And so those are really, really important to maximize the value that you're getting out of a Kubernetes based deployment, or really a cloud native based deployment. So why don't databases just do that? And so secured access by default. So configure one place, have it pushed out to all of the Kubernetes deployments, who can access what, at what times, those types of things. And then using every single bit of the capacity that you have. Don't have any replicas for the sakes of replicas. Have replicas actually doing things that you need to either offload reads, have multiple write nodes, and then one big aggregate for analytics. All of those things should be possible with a Kubernetes-based deployment with a database built in mind with it. So, what are possible answers? Well, distributions are, I think, a viable possible answer. And what we've seen is Kubernetes Sandra from DataStax. And what they're doing is intentionally saying operators aren't enough. We have to build some type of ecosystem or deployment methodology around Kubernetes that uses the best that we have to offer from a Cassandra, right? And so base Cassandra, and then we stitch together a bunch of tooling, our operators, and everything to make that work and build purpose-built applications specifically for Kubernetes. So I think this is a really good lead in, and it opens the door. But one thing that we're still missing is the database itself acknowledging that it is deployed on Kubernetes, and that means something different. It can do different things now that it's not just on some base Linux OS or Windows deployment. And so maybe the answer could be downstream products that have completely differentiated feature sets where it's not just, oh, we're going to build a Kubernetes flavor of MySQL, or Postgres, or Mongo, or Redis, or Cassandra. We're going to build a different product that is specifically MySQL for Kubernetes or Postgres for Kubernetes, where it's a totally different mode of operation. It's different configuration variables are available. And these should probably be standalone products with their own engineering teams that maybe inherit upstream and make their changes, patches, whatever they need to do, and then bolt on all of this other additional functionality to that database. So not a main branch of that database, but literally a different product. That could be something that we see that could be pretty interesting. And then a lot of benefits to that NewSQL that people that have been able to develop since Kubernetes was a thing. We started to see this where we abandon the old world. We say we're done developing just to run on Linux or just to run on a single node, because who runs anything on a single node in production in 2021? You can easily just split that into two much smaller containers, run it on different machines, and then poof, right? You instantly gain much more availability. It's safer. Everything is gotten cheaper from a storage perspective. There's really no reason to run just a single node in production anymore. And so that is true, but that's not necessarily true from a VMs and bare metal and everything else perspective. And so what I think this does is it kind of creates a chasm intrinsically of people who want to keep a traditional deployment model where they really like all the automation that they can build. They love Ansible. They have all kinds of really crazy workflows that they do. And they do that kind of at the lowest level of resource. And then you have the drive consistency everywhere from Kubernetes approach. And we really have seen some great examples of this. So TiDB is Kubernetes first. They're cloud native. They're CNCF. They're a graduated project. They built TiDB with Kubernetes in mind, and it's one of the best examples that I can think of that leverages aspects of Kubernetes within the database itself instead of just as an afterthought or a bolt on to. You actually lose functionality if you deploy it a different way than in Kubernetes, which is really cool. But then it's not so cool for the people that aren't deploying it in Kubernetes. And I understand from a commercial perspective why that may not make sense as a deployment methodology. Cockroach is a good example. I brought them up earlier. I don't think that they're leveraging everything they can. I think they're trying. They're making a really good, valiant effort. They also kind of came into the game a little bit after Kubernetes was really a thing, and they've really done a good job of going and revisiting that and making it a modernized thing. And so treat non-Kubernetes deployments as second-class citizens is kind of mandatory for this deployment style. And I hope this got the juices flowing for some of the people that write this database management software. And this is the end, but only for now. Feel free to ask me any questions. I'm pretty active in the Data on Kubernetes community in the Slack. And Bart, back over to you, bud.
Rick, you are the Data on Kubernetes community. If there is no Rick, this doesn't exist anymore. So anyway, Rick is awesome. And when he says that he's serious about answering questions, he really means it. Put him in the YouTube chat, put him in Slack. Rick is no stranger, and we're going to see you back soon. Rick, thank you very much.
Cheers.
Best. All right.